Okay, in this lesson, we are going to be solving rational equations. And so when you're solving any kind of equation, remember you're looking for what x equals or whatever variable they're using. And so for rational equations, you need a common denominator. So for a simple example, if you had the rational equation x over 6 equals 5, 6, if the denominators are the same, that means the numerators have to be the same. And so you would be able to say x equals 5. And so if the denominators are not the same, so for example, if I said x over 2 equals 5 over 6, you could get a common denominator by multiplying top and bottom of this first fraction by 3. And then it would say 3x over 6 equals 5 over 6. And so when the denominators are the same, you get to ignore them and just set the numerators equal to each other. And so in this case, we would have the equation 3x equals 5, and we would just need to solve for x and get x equals 5/3. And so that's the strategy. We're going to get a common denominator, and then we are going to ignore the denominator. So looking at number 1, we need a common denominator across this equation. And so we've almost got one. We've got x minus 2, but this x here also needs the common denominator. I wrote it over 1 because if there's not a denominator, the denominator is 1. And so he also needs to have the denominator x minus 2. And so we're just going to multiply top and bottom by x minus 2. And now all 3 places have a denominator of x minus 2. And so I can just focus on the numerators. And so my first fraction, it has the x times x minus 2. I like to put the x first so I can distribute it. And then we have our plus sign. And then we have an x. Then we have our equal sign. And then we have the 2. And so now to simplify this equation, we distribute the x and get x squared minus 2x plus x equals 2. Combine your like terms. We're dealing with a quadratic equation. We have an x squared term. And so whenever you have an x squared term, put everything on one side and try to factor it. So we need two numbers that multiply to -2 and add to -1. That's -2, +1. So x minus 2, x plus 1. And so our solutions would be x equals +2 and x equals -1, the opposite of the factors. And so before you commit to these as your final solutions, we have to remember that rational functions have domain restrictions. And domain restrictions are where the denominator equals 0. You can't have 0 in the denominator. And so because the denominator can't equal 0, we have to make sure these solutions don't create that situation. So our domain restrictions here would come from the x minus 2 not being 0. And so x cannot equal 2. That's our domain restriction. And so because we have x equals 2 as a solution, we would need to mark that as an extraneous solution. And our only actual solution would be the -1. And so that's why it says list the domain restrictions and check for extraneous solutions. Because if one of your solutions is part of the domain restriction, it can't be a solution. All right, for number 2, we need a common denominator. And so our denominators are x minus 3, x plus 5. And then we have a quadratic that we can factor to x plus 5, x minus 3. And so the LCD between these 3 denominators would need the x plus 5 and the x minus 3. The LCD has to be divisible by all 3 denominators, and this would do it. And so my first fraction needs the x plus 5. My second fraction needs the x minus 3. And my third fraction already has that denominator, so we don't do anything to that. And so now we can focus on the numerators. We have an x and an x plus 5 that we're going to have to distribute. We have a minus sign. Then we have 7 times the x minus 3. Then we have an equal sign. And then we have a 24. Distribute, you get x squared plus 5x. Distribute a negative 7. Negative 7x plus 21 equals 24. We're dealing with a quadratic, so let's simplify by combining like terms, and then subtract the 24 from both sides and try to factor. And so we need two numbers that multiply to negative 3, add to negative 2. It's going to be negative 3, positive 1. And so we have our factors, and then take the opposite to get your solutions. Now we need to find our domain restrictions. And so our domain restrictions are going to come from the LCD. And so we have to make sure x cannot equal negative 5 and x cannot equal positive 3, because these are the factors in the denominators. And so looking at our solutions, x equals 3 would be an extraneous solution. And so we would only have x equals negative 1 as an actual solution. Okay, looking at number 3, our denominators are x plus 4, x minus 3, and then this quadratic factors to x plus 4, x minus 3. Usually it factors to the other denominator, so if you need a hint, look at those. And so our LCD would be the x plus 4, x minus 3. And then while we're at it, let's go ahead and write out our domain restrictions. X cannot equal negative 4, x cannot equal positive 3. That way if we run into them, we'll know it's an extraneous solution. So my first fraction has the x plus 4. We just need the x minus 3. Second fraction has the x minus 3. We just need the x plus 4. And then third fraction doesn't need anything. Focusing on the numerators, we have a 3x times x minus 3, a plus sign, and then a 4x times x plus 4, our equal sign, and then our 84. Distribute, we get 3x squared minus 9x plus 4x squared plus 16x equals the 84. Combine our like terms, we get 7x squared plus 7x equals 84. Move the 84 to the other side. And then we actually have a GCF of 7 here, and so we can divide each of these numbers to simplify things. And so factoring out a 7 technically would give us x squared plus x minus 12. And then that's going to make this a lot easier to factor. We just need two numbers that multiply to negative 12 but add to 1. That's positive 4 and negative 3. And then as we're solving for our solutions, this 7 doesn't have an x with it. So technically you could divide both sides of the equation by 7 and ignore it. You would still have 0 on the right-hand side. And so x equals -4, x equals +3 are the only solutions. You only get a solution where you have an x, so there's no x here. And so it turns out these were our domain restrictions, so both are extraneous, and so we don't have an actual solution, and so we would say no solution for our final answer. Looking at this next one, number 4, this factors to x -4, x -3. And so our least common denominator is x -4, x -3. Our domain restrictions, x cannot equal 4, x cannot equal 3. First fraction needs the x -4. Second fraction needs the x -3. Third fraction doesn't need anything. We have 3 times the x -4 plus 4 times the x -3 equals 25. Distribute, we get 3x -12 plus 4x -12 gives us 7x -24. And then this is just a linear equation, so we don't have to factor it, we just need to isolate x. So add the 24, divide by 7, x equals 7. That was not one of our domain restrictions, and so that is our final solution. I'm just going to do 5 and 6, and then we will be done. And so 5 is a little bit different because we have this equal to a whole number. And so when that's the case, go ahead and write a denominator of 1 because we still need to get a common denominator across the board, including that 2. And so we have x -3, we have x -6, and so the LCD here is going to need both of those factors. And so our domain restriction, x cannot equal 3, x cannot equal 6. And so my first fraction here, he's got the x -3, he just needs the x -6. Second fraction needs the x -3. And then here, this is the first time we've seen that the third fraction needs both factors. He didn't have either. A lot of people forget that he needs them too. Okay, and so now we have a common denominator across the board, focusing on the numerators. We have x -6 times x plus 2. We're going to have to FOIL that. We have a plus sign, x -2 times x -3 equals 2 times x -3, x -6. Lots of foiling happening here. So first FOIL, we get x squared minus 6x plus 2x is -4x minus 12. Second FOIL, we have x squared, and this is a plus sign, but if it were a minus sign, you would need parentheses around these. I'm going to go ahead and do that. It's a good habit. And then we would get a minus 5x plus 6 equals, I'm going to leave the 2 out for now. In FOIL, we get x squared minus 12x plus 36. Combine our like terms, I get 2x squared minus 9x minus 6. Distribute a 2 over here, we get 2x squared minus 24x plus 72. Oh, no, that should have been x minus 3. x minus 6. Sorry. Back up. I don't remember the numbers getting that large. So that foils to x squared minus 9x plus 18. So we get 2x squared minus 18x plus 36. And then as we move everything to one side, our 2x squareds would cancel. And so that leaves us with another linear equation. And so I'm going to add 18x to both sides. And then add 6 to both sides. Divide by 9. And then if you get a fraction, you always want to simplify that fraction, I believe. They're both divisible by 3. So 14 over 3. That wasn't one of our restricted values, so that is our final solution. Okay, number 6, there's a trick to it. And so here we have x plus 2 as one of our factors. This 2 minus x, that's not written in the correct order, so you would want to rewrite it to where the x is first, keeping the negative on the x. And then whenever there's a negative on the x, you want to factor it out. And so that's the same as negative x minus 2. And so we can rewrite this problem. And then this negative can go up on top and cancel with this negative here to make it plus. And then x squared minus 4 is a difference of squares that factors to x plus 2, x minus 2. So now this problem is going to be a lot easier. And so our denominators are x plus 2, x minus 2, and then x plus 2 times x minus 2. And so that is going to be our LCD. And so we can write our domain restrictions. X can't equal positive or negative 2. And so my first fraction just needs the x minus 2. Second fraction needs the x plus 2. Third fraction, he's got that full denominator. So focusing on the numerators, we have 2 times the x minus 2. We have a plus. And then we have an x times an x plus 2. And then an x squared plus 4. Distribute. We get 2x minus 4 plus x squared plus 2x equals x squared plus 4. And this is another situation where our x squared cancels out, leaving us with something linear. 4x minus 4 on the left side and 4 on the right. Add 4 to both sides. We get 4x equals 8. Divide by 4, we get x equals 2. That was one of our domain restrictions. And so our only solution is extraneous. And so we're just going to say no solution for our final answer.